Today's topic is construction and properties of the single phase motor. So single phase motor got only two construction similar to the three phase induction motor. So there is the stator winding and the rotor. Rotor is the diameter iron cores are utilized for the stator and rotor. And stator core is made of the hair in the motor frame. And also the rotor is a square gauge rotor. So cover bars are welded together at the both ends to form a rotor. So by the way, the starting conditions are induced current is higher. So in the to wind a square gauge single phase motor. Single phase motor usually require the two winding. One with the starting winding and the running winding. So starting winding is to provide a starting torque, and then this winding is small winding, and there's a few number of turns and high resistance. So we have to cut off the starting winding once the motor has been completed. And running winding is a single phase winding that will on the motor pool. So by this way the motor is provided. So starting winding function only to start the motor, and running winding is to continue to run the motor. So depending on the kind of the motor construction, there will be the split phase motor or the capacitor start motor, capacitor run motor, and universal motor, and the straight flow motor. So those motors are the kind of the single phase motor. So for the single phase motor, so we need to cut off the starting winding and other motor having separated. So we can cut off the starting winding by the two methods. One is the centrifugal switch. The centrifugal switch is connected in series with the starting winding. So this is why when the motor is PR, the centrifugal force cut off open the switch. Open the switch so that by the way the starting winding can be cut off. And another one is starting relay. So starting relay is mostly utilized for the home refrigerator motor, compressor motor. So your refrigerator got the compressor. So compressor is controlled by the starting relay. So the starting relay function is only job for starting motors, and after the motor is completed, the relay cut off the starting winding. So this is the way that we construct the single phase motor. So single phase motors are mostly utilized for the low power applications. So but motors, when the motor are bigger than the 5 horsepower, in this case we should utilize the 3 phase motor. So now I give you the notes and the construction for the single phase motor. Application will be divided. So there will be the split phase, capacitor start, and the capacitor run, universal, shaded flow, the hysteresis motor. So those are the kind of the single phase motor. Data connection, the construction. So the single phase motor can be the starting winding and running winding. Starting winding plus and running plus are 90 degrees of phase difference. Starting winding needs to be the cut off once the motor is separated. So the single phase motor can be divided into a classification: 3 phase, capacitor start, capacitor run, universal shaded flow, and the hysteresis motor. So the stator can the laminated stator core is made from a sheet steel, stemming with a slot in the inner surface. So that the slots are already formed, so they are set together. And the stator core is carrying the motor frame, which also starts to carry the bearing holding on the rotor to protect the coils and to provide means whereby the whole can be mounted. So that the motor stator is functioning to hold the coils as well as to mount the bearing. So the motor frame can take the various form. So frame can be some will be drip roll type. So drip roll type means that water cannot come inside, and also it can also do the ventilation, and totally enclosed type prevent the action of the air between the inside and outside of the frame. So this is depending on the motor where you use the motor. And so you use at your home, this is not too much problem. But as for you use for the very corrosive place, in this case, motor should be totally enclosed. For the workplace or the industry, refrigeration industry, motor should be the drip proof. So some motors are underwater motors, so we put a totally immersed motor. So this should be the totally enclosed. So depending on the place of the application, the motor frames there should be the appropriate kind of the motor frame to be utilized. So this is what is a stator construction. The rotor will be the spiral induction motor rotor. So rotor consists of the shaft with the bearings, the laminated iron cores, and the rotor are pointed out. So this is the rotor bars in the laminated slot are the inserted. So rather than the winding, so there is a square gauge induction motor does not have a rotor winding. Instead they call it a square gauge rotor bar. But for the one rotor motor, it called it winding. So one rotor motor function is you can change the speed of the motor that inserted the series system to the rotor package. So the rotor of the three-phase, the rotor of the induction motor consists of the shaft and the bearing, laminated iron cores, and the rotor cotter. The more commodity of the construction is best. The rotor bar in the laminated slot rather than the winding. The rotor bar short circuited at each end by a solid ring are often made of the copper switch, whether to the copper ring. But for the small and medium size motors, they are cut in the one piece of the aluminum. So this is for when you see the induction motor, you can see the motor like this. This is motor. So then you say you got rotor bars are connected like this. This is for the induction motor. So this is for the rotor construction. In this case, there are two types of rotors. This is for the square gauge rotor. The one rotor also called as a winding. So when you have the motors operating, they are the rotating magnetic field, the cross field and the revolving field theory. They are based on the cross field and revolving theory. So motor rotation. So there are two magnetic flux, cross magnetizing flux. And revolving field. So when you connect a rotor straight up with a supply straight up to use a rotating magnetic flux, so those magnetic flux are passing through the rotor and they cross the rotor, and so the rotor will be saturated. So this is the way the motor is running. For the single phase induction motor diagram, so induction motor single phase motor is you can see that how the motors are winding. So that way is running winding. So between this one we just this is a state rotor, and then this one is connected to the starting switch. So this is start winding. And this is connected to the single phase supply. So this is for the construction of the single phase motor. So how is running winding and starting winding are constructed? So their construction is at 90 degrees out of phase. For example, this is we can use this for the running winding. So when you see the motor, the first thing we use this black one is the running winding. So running winding is first thing we put at the back, and then on the running winding. So 90 degree phase difference, we put at the starting winding. So this is the starting winding we like it. So this is blue one is the starting winding. So we hold as a starting winding and a running winding. The running winding is black one and the starting winding is a blue one. So that the winding waves are 90 degrees are phase different. So at the middle, so we have put the starting and the running winding. So by making the starting and the running winding at 90 degrees, so we can produce the starting current and the running current. So this is for horizontal reference line. So that way this is battery is running this way. So this is for the IST starting current, and this is the I run running current. So this one is normally not a 90 degree phase difference. So if you want a 90-degree phase effect, you can use a capacitor. By putting a capacitor, that will be a 90-degree phase effect. So this diagram, you can draw this waveform diagram. So waveform diagram is a this plug will be the pi st, and another plug will be the pi lam. So this is winding potential, and there's a produces a current, and this is the plus waveform diagram. So this is the way the motors we constructed. So this motor constructed means that so when we want that this starting current and running current are 90 degrees, so you have to utilize the capacitor. So normally this kind of motor is we call it a split phase motor. A two-phase motor. So split phase motor has not got and these are capacitor. So you can connect the capacitor. By connecting the capacitor, the plug will be the 90 degrees. So in this case, this plug can be modified by the inserting the series capacitor to the starting winding. So in this case, there will be the running winding here, and then here we use the starting switch, the capacitor, and the starting winding. Then you can connect the supply. So this is the motor, the rotor, so this is supply. So by connecting this one, so you can increase the many plus sign. So this is for the reference line. So then we use the IST. So this is the IRAM. So this is different with the 90 degrees. In the meantime, the plus also that you can. So this one with the plus we use the pi ST. So this we use the pi RAM. So then we use the 90 degrees. So 5 ST, so 5 RAM. So we can use this stuff. So this is starting capacitor function. So this is the CST is a starting capacitor. CST is a starting capacitor. So by connecting the starting capacitor, the motor starting current and running current will be the 90-degree phase effect, and the motor torque is improved. So this is the point we have to utilize the starting capacitor motor. So capacitor motor provides a better starting the torque, but this capacitor value should be the appropriate value. So when the motor is not starting properly, in this case you should check the capacitor. That provides 90 degrees phase difference between starting and running flathead, and the current and the provide a higher starting torque. The capacitor motor function is only the capacitor including the starting die. But at the shunt motor also called the running capacitor. The running capacitor function is to provide not only the provide the starting, but also provide the power factor improvement. So in this case, there are two capacitor values. So one capacitor value is the only included only for the starting die, and another capacitor is permanently connected to the starting winding. So it's also included the running die. So this is we call it a capacitor start and a capacitor run motor. So the other motor has been separated. The starting capacitor is to be cut off. Only the running capacitor is connected in series with the starting winding, and the motor power factor can be improved. So that kind of motor will be the capacitor start and the capacitor run motor. And another one will be the this capacitor arrangement. Standard capacitor can be arranged to in series with the starting winding, but in some motor, the capacitor value is common for both the starting and the running winding. So this kind of the capacitor will be the permanently split the capacitor motor. So now I give the circuit diagram for those motors. For the permanently split the capacitor motor, auxiliary winding, another will be the round main winding. So this means that this switch is a two-way switch. So two positions. At the starting position, the capacitor is connected to here. So this is for start. And this is the run. The starting position, you put the switch position 1. So this means the auxiliary winding and the capacitor are connected in series. And that's when the running winding this one goes to here. So this one capacitor in series with the main winding. So by this way you can improve the power factor. So they are the construction of the configuration of the different kind of the motor. So we can do this specific motor, but it's a characteristic not starting characteristic. So it's a poor So that to input a starting torque, you have to use the capacitor. So that way capacitor start motor. And also use the capacitor start capacitor run motor. So that way just C start is connected in series with the starting switch. And C run in series with the starting wiring. And then the permanently split motor means that there's two positions, starting position, start position. So in this, it's a at the starting time, so the auxiliary winding and the capacitor connected in series so that we can input a starting torque. And at the running time, we change the switch to the run position so that main winding and the capacitor are connected in series. So that the same capacitor is the function that it provides a starting torque function as well as a power product improvement function. So this is a permanently split capacitor motor. Now with the shaded full motor. The shaded full motor is the function is for the three-phase for the electric motor, there is three-phase or at least a two-phase. Although the single-phase motor we can link as a single-phase, it's really the two-phase. Two-phase means that it provides a starting and a running. So starting winding and running winding have a 90-degree difference, so the two flags are 90-degree different. So two flags are interact and the motor will run. The shaded full motor does not have that winding. Instead of the pole-piece is shaded. Pole-piece shaded means that we use a shaded full motor. This is a one pole here. So this pole is a slotted. And here we put a shading ring. And another pole is very like it. And we put a shading ring. So between the six poles we put a rotor. Rotor. So this is rotor. So this is shading ring. So this is for the pole. So in this case, plus are produced. Plus will use means the plus are phi 1 and the plus phi is produced. So this is a phi 1. So plus phi 1 and the phi 2 are produced by the shading ring. So this is for the plus phi 1 here. And this is the phi 2. Here is a phi 1 and a phi 2. So phi 1 is greater than the phi 2. So therefore the motor will rotate from this position, this direction. So this is the pole is shaded and we put a shading ring. By putting the shading ring, the plus can be the difference. So that this shading ring affects plus phi 1 can be this direction and the plus phi 2 is this direction. So this one. So by this way that you can shade it up better different. So you can make a better different by the shading ring. So that this is a shaded pole motor, is that we can use a small cloud motor. So this does not have a winding. Winding can be whole. Winding is not on the floor. The windings are on here. This is the windings how we put the winding here. So this is what, and then this is equal to the supply. So this is the winding connection. So the shaded pole motor, by using the shaded pole motor, the two plus are different signs, plus different cross line the shading ring, so the motor will be rotated. So this shaded pole motor direction is difficult to reverse. For the capacitor motor, you can reverse easily. This motor is connected here. So this connection. So this is the motor rolling in this direction. If you connect the motor, the reverse connection. Reverse connection means that this winding go to this direction and this one connected here. So in this case, motor will rotate in the opposite direction. So this is for the supply. So this means that if you want to reverse the three-phase motor, so you have to change the one phase. One phase connection you have to change. So line 1 is connected to line 2, line 2 connected to line 1, so motor direction will be changed. For the single phase motor, you want to change, so you have to change the connection of the starting winding. So reversing the starting winding, motor will be reverse. So this is for the reversing the rotation. Reversing motor rotation. Touch. The shaded pole motor, you cannot reverse easily because the shaded pole is permanently fixed. You can reverse the direction of the shaded pole motor. So this is the motor construction. So all the single phase motor, we call the split phase motor, and the capacitor run, and the shaded pole motor. It's a universal motor. So universal motor means we can use a motor by both the DC and the AC supply. So the motor construction very much similar to the DC motor. So this universal motor means the motor speed can be very high. Normal motor speed is limited by the n equal to 120 FIP. N equal to 120 FIP, this is the other motor. So other motor, AC motor. Speed n is equal to 120 F divided by P. It follows the equation. So number of poles and then the frequency. So maximum speed you can get is 3000 RPM because to run a motor it needs at least 2 poles. So in this case, maximum speed can be 3000 RPM. First one is universal series motor. Universal series motor can get the highest speed. 10,000 RPM, 20,000 RPM can be provided because this motor is combined with DC car. So therefore, if you want to make a country, so drilling needs a very high speed. So in your drills are a very high speed. So those drill machines we usually use the universal series motor. Connection diagram of the universal series motor. Next topic we use a comparison of the single phase and the three-phase motor. So especially the three-phase machines are the advantage because they are smaller. So with the same power rating, so three-phase machines are the smaller and more compact. So they provide the higher efficiency, and also there's a superior for the power line frequency. So no studying mechanism required, no additional wiring will be required. So this is what the characteristic advantage of the three-phase induction motor. Such three-phase motor also got a disadvantage because of when you roll it out three-phase winding, all three windings must be identical. If you roll a single-phase motor, it's not necessarily to identical the main winding and the auxiliary winding. Main winding and the auxiliary winding different, no problem. Single-phase machine can run, but three-phase machine cannot smoothly run. It's the winding side. Winding resistance are very important in the three-phase winding. So that you have to measure the three-phase winding resistance. So if the resistance are very significantly different or the winding stance are different, so three-phase machines cannot run properly. This is the point that these three-phase machines are the more at the disadvantage of the single-phase winding, the single-phase motor. But the single-phase motor advantage is that got the two winding. But this advantage means that these windings cannot draw the too higher current or too power, and also they cannot run this very heavy load. So this is the disadvantage. So this is the things that we different between the single-phase and three-phase. And normally the three-phase machines are utilized for the industrial application, but the single-phase machines are utilized for the domestic appliance, hand tools, and also the low power machinery. So we use a single-phase machine. So this is the differentiation between the three-phase and the single-phase motor. Okay, the next one topic will be the abnormal operations of the three-phase induction motor. So abnormal operation collision happens when the three-phase motors sometimes phase reverse. You connect the one phase and reverse connection, so motor will not run properly. So motor makes a humming. So this is the phase reverse. It's abnormal. Another way the single phase in. So two phases out, only one single phase left. So it is a motor will not run at all. And also the overloading happen. Overloading happen means sometimes overload is caused by external load, but sometimes the bearing failure. Bearing function should be small. Sometimes very jam, so the motor will not run properly. So this is also called the overloading. Sometimes the clearance between the motor when you are fix the motor. This is the motor here. This is motor. This armature. So this was the end plate. Airplane and the motors rotor should be clear. So sometimes you fix the things the airplane is sometimes they not clear with the motors rotor, so rotor will be overloaded. So you can see that the width of the connecting any load, motor is drawing the higher current, so circuit breaker trade off. This is the way that we have. So this is I ever faced this similar thing on the ship. So that is how we use it in the chit, we use the water pumping system. Water pumping system is seawater or the fresh water, you use a pump. So water pump motors are usually we install. This is the motor here. This is vertical type, and after the here you got the impeller. Impeller, and this is a pump. So this is the motors are rotating, so the pump are sucking, and this is suction like this. So this is motor like this. So this is for sometimes why we say we find got a problem. Some got a problem as soon as I just switch off, whenever switch off, find a trade off, and the circuit breaker to find a trade off. But we don't have. But the time is firstly we shut down the sea water valve. So water was in there, outlet valve we shut down. Firstly, we thought that because of the overload, but the overload is a water motor is very seldom to face the overload because different from the other machines. Other machines are saw cutting or the motor can be overload, but this one water is a constant. So what happens? So we close the bar and we start again. The motor still got the problem, and then we open the motor. Open the motor. What happens is this imbalance is pulling down. Pulling down is they can start with the body. Because this screw is when running the screw is loose. This screw loose and this screw is screw at the here is loose and this motor attached to here. The shaft will be the longer and so motor is there are a lot of friction between the motor and the pump body. So this motor is overloaded. So motor overloaded is also important. So how can you determine the overload and the short circuit? Okay, give me the answer. When you see the motor, you can see. So how can you identify the short circuit and overload? Yes, both are treated circuit, but for the treated circuit means a three-way circuit breaker you cannot properly identify because once they treat all the things are treated all together. But if you use a fuse system, this is for the motor as a fuse. Sometimes this circuit breaker are also the breaker with a fuse. So three-phase means when the two fuses are one fuse is only one fuse blow out, that will be the phase you pay up ground for. And two fuses blow out, that will be the phase you pay for. But three-phase usually all three fuses are broken down. So that model we saw that this model also got a circuit breaker and a fuse. Both circuit breaker and fuse are cut off, but we see that all three fuses are gone. So this means that we can say that this is the overload. So when you open the thing, so we found like this. So it will embellish the cool house and so they got a lot of friction. So normally we can identify. So but if you use only the three-phase circuit breaker, difficult to identify because all circuit breakers are off at the same time. But if you use the fuse, you can identify more. So this is why the sound system we use both the circuit breaker and the fuse together. Because the pure fault condition. In the meantime, fault also can happen due to the voltage fluctuation. Voltage fluctuation means in Australia is very seldom to face the fluctuation, but in some the developing countries voltage fluctuation too much, and also the high operating temperature and frequency variation. Those things are cause the motors are abnormal operation, and also when the motor is started, so there is a frequency starting. Frequency starting means here is not too much problem. We use a refrigerator, so you buy the one refrigerator, you can use the 5 year, 10 year, no problem. But in our countries, we got a very problem because of the sometimes supply voltage go down. Go down, we use a 230 volt system. But sometimes voltage go down 200 volt, sometimes go to 150 volt like this. So that is the most things of victims are the refrigerator. When you are using a refrigerator, okay, so refrigerator is usually start, compress, and then stop. Firstly, we notice the starting and the stopping time is really quicker. Firstly, the support is like every 1 hour compressor starts, then you can see that the 30 minutes or the 15 minutes like this. So 30 minutes, 15 minutes, so that this is a more high frequency start, so this is a bigger notice. This one is starting. And then what happens is motor start, so we bring the refrigerator to the repair. The repair means in the here is we your revision logo, you cut out and you put on the road. So sometimes we look after it. But in our country, we can buy because this revision is too expensive. So what happens is the revision cut it out. So the revision body they have to cut, they open, and the injections are compressor windings are take out, they replace, and then you put. After that, you have to solder again, and you have to recharge the meter mic, take it off, the pressure, everything take out, and then you recharge. So this is a lot of the service. So what happens is sometimes the repair, the motor usually called the starting switch. The one motor cut the starting switch, cut out, they bypass it. Bypass it, and then they go back. So those people who buy it, who are the customer is happy because of the motor revision can run. So they about the 1 month, 2 months, they totally blow out. Sometimes even the supply wire blow out because of they bypass the starting switch, so the motor withdraw the higher current. Motor is initially the motor winding is weaker, so there's a they draw the higher current. Higher current, they bypass the startings are relay, so this is a motor withdraw the high current. Even an electric fire can happen. But here you are electrician, you can do like this. The people complain your license will come. But our country no problem. You can in the bar everything no problem. And the cost of the abnormal operation. So abnormal operation of the three-phase motor. To run the motor smoothly, the following are required. 3 equal bodies at the corner phase distribution. Theta winding being connected in either star or delta configuration. 3-line bodies being connected to the motors are winding. So the abnormal conditions that can happen, the phase reversal or single phasing, overloading, body fluctuation, higher operation temperature, frequency variation, frequent starting, misalignment of the shaft, jamming of the bearings, blocking of ventilation dust, and the overheating. So those are the motors that cause of the abnormal operation. So in this case, you have to check the motor. So usually it's maintenance. Maintenance means that you have to make the continuity test. Continuity test means that from the motor winding, you have to make the test. So all the three-phase windings must have the same the system. So we have to do the continuity test. Another one, we also have to do the insulation to add test. In this case, you have to use the mega. The mega means the motor winding terminals are connected to the insulation resistance between the motor winding and the terminal have to be done. And also the insulation test between the winding. So winding to winding insulation test have to be done and the visual inspection. So you see the visually inspect whether motor is overheating or not. And especially that you can see that the motor supply. The most important is that not only the motor, the conductor. In this case, we use the electro cleaner. When you meet the conductor are properly charged. So all the three-phase conductor, all conductors must be properly charged. So sometimes there are a lot of dust or a lot of sparking happen. So in this case, in this two conductor will not charge properly. So if there's one conductor is not charged properly, only 2 conductors are touching. In this case, motor can be the one phase out. Only 2 phase of motor will not run properly. So it can happen like this. So not only the motor, you check the motor, but also you also need to check the conductor, and the conductor need to be properly cleaned like this. So this is the especially the motors are frequently start and stop. That motor is a frequently start and stop. Sparking happen between the conductor. So in this case, conductor needs to be checked properly. So this is the important aspect to check the motor. And also when we are using the motor for long time, so that you need to regularly upgrade the insulation. Upgrade the insulation means that insulation is that you take off the motor winding and you pull out the insulation and then you break the insulation and then you have to put back and then you run the motor this way. Everything by out you have to rewind. But the thing is that we don't allow the motor to rewind. So we have to check the motor insulation upgrading. So by upgrading the motor, you can avoid the rewinding stage. But rewinding is very costly because when you rewind the motor, the most first thing is that you have to use the ordinary initial motors collision. So how many number of times? Normally we work on the motor repair shop. So we have to count the motor. So we have to use the initial number of times. How many times you have to count, and we have to measure the gain of the time into the winding and also quiet span, how the quiet span going. So especially the industrial motors are very seldom to use a single winding. In this case, you use the winding of pairing. 2 or 3 windings together to remove the wound motor. So this is one. Another thing is a TV pedal connection we also utilize. This is for the big motor. So all the data need to be the proper liter you have to take in, and then so also insulation class is also important you have taken. And other than that, when you put the winding and you have to usually put the wedge. So in our country we usually use the bamboo wedge. Bamboo wedge this is the motor slot. So in the motor slot we move the winding. So this is the motor slot, we put the insulation here, and then we put the bamboo wedge here. So this way is very important. Normally in our country we usually use it like you knife and you cut the thing. So these people are very they very precise. They cut everything precise. Not to be too small or too big. The most important one is especially the DC machine. AC machine is not too much. DC machine is the armature is rotating. So the jaw wedge are no good. Jaw wedge will go down, coming out. Coming out and it hit the all other things, so the whole thing will be damaged. So this wedge is very important. So this is after you put the wedge, you have to properly also tie it with the iron bed like this. So that this wedge cutting connection is also important. Another one is important one is that this is a motor slot. Motor slot before you put the energy winding, you have to put the insulation. So this insulation you have to put should be the appropriate cover. The insulation this height is very important. Sometimes this height is too short. What happens is that when you put the winding, so winding is normally put the winding. So this insulation originally look like here, but the other than will be like this. So this is the gap. This gap. This gap and then windings will be touching. So windings normally is enamel wire. Enamel wire is an enamel coated. Coated meaning insulation coated. But it is not too good because of this windings, this iron body and this insulation are cutting, so it can cause upfall. Upfall can happen. Upfall is too dangerous. Some of the operator can die because of upfall. So these upfalls are upfall you can still run the machine. So but the danger to the people. So because of this one, when you are rewind, you have to cut the appropriate insulation paper. So we use the leatherite paper. Cut the appropriate leatherite paper, appropriate height. So there should be a nose gap between the winding to the then so the winding can touch to the strong. Yes. Paper is not no good because the paper is some people today use our country, sometimes you use, but paper is not too good. But we have to especially you have to use at least leatherite paper. The light paper is special insulation paper. Yes, that's what says the fire. Motor maintenance. So electrical test for the 3-phase winding has to be done for the continuity test in relation to our test. Insulation test between the windings, visual inspection, regular insulation upgrading, winding resistance tests are important for the motor maintenance. In the meantime, for the rewinding, the point span, point grooves, number of conductor, size of the conductor, connection, windings are the systems are to be recorded for the making and identical winding. So this is for the important characteristic of the single phase and the 3-phase motor. There are operation abnormal condition, difference between differentiation, and also the maintenance. Now I can also talk to the torque and the horsepower of the single phase induction motor. This is the equation to calculate for the motor. So motor horsepower can be calculated. Speed multiplies 2 by n multiplied torque is Newton meter, and the multiply with 33,000. So long rotor torque is torque of that long rotor. So you hold the rotor cannot move. So this is the torque required. And breakdown torque means the torque that store the motor. When the low torque is too high, so motor cannot run properly. So this is what the torque to store the motor. So this is what the long rotor torque and the breakdown torque here. So in this case, long rotor kVA by horsepower can also be calculated. So long rotor ampere. So when the motor is rotor is long, you can also calculate the long rotor ampere. So 1,000 multiplied horsepower, multiplied the kVA by horsepower, and 1 by 73 multiplied the volt. So this is been. So in this case, motors are code letter. So motor winding got the code letters A, B, C, D. So this is what depending on the kVA by horsepower, we can call the is motor code letter. In this case, you see it in the motor winding. So this is windings are motors are type A, type B, type C, type D up to the type V. So in this case, kVA or horsepower will be the from the 0 to 3/15 up to 22/4. So this is for the loud rotor rating. This is a motor. So motor is similar to the transformer equivalent circuit. When you draw the transformer equivalent circuit, you can draw the thing. Then we the stator winding and the rotor winding. So stator winding and rotor winding are connected together. So by this is we can form a motor and the transformer winding. So for similarly the motor winding also called as equivalent circuit. So in this case, motors stator is similar to the primary winding, rotor winding is similar to the rotor winding similar to the secondary winding. So in this case, in the transformer 4 called as hysteresis loss and the eddy current loss. So this is the parallel branch. And similarly, motor also called as hysteresis and eddy current parallel branch. So for the three-phase motor, so we can sort the three-phase motor by the single-phase equivalent because all three windings are equivalent. So that instead of using the three-phase winding, we use the only single phase. So that we find the phase wave voltage and all the things. Stator winding and the rotor winding, we use the single equivalent circuit. But for the single phase motor is the stator and rotor windings are not equal. So you can use a single line diagram equivalent. So in this case, you have to use the two winding. So this means that this is for the single phase motor, both the stator winding and rotor winding, they call the equivalent circuit diagram. So two equivalent circuits are connected in parallel for the single phase motor. So therefore, I draw the equivalent circuit for the single phase motor. We need it. This is for this way here. So this is the motor stator winding, and this is the rotor winding, inductor and the reactant. And this is the branch. Branch means that this is for the magnetizing and the hysteresis loss component. So this is for the motor. So in this case, we can use the equation. So this becomes R1, and this is the H1. So this is the R2 by the slip, and this is the H2. So this is for the Rn and Hn. So this is for the we can use a stator winding. And similarly, we can also draw another winding for the rotor winding. So then we use R2 for the rotor circuit. So this is for the starting winding. And also we also got the running winding. So running R2 and the H2. So this is for the better we put the RS and HS. So this is the H2S and R2S. And this is for the RR and the HR. And so also this is the HR2, H2R. And this is for the R2R. So this is for the rotor winding resistance. Rotor windings are resistant, and stator windings are stator wind. So this is the stator windings are reactant, inductive reactant, and this is for rotor equivalent. So this one also called as winding here. So this is Rm and the Hn.
So what's that
H2S. H2S means the rotor winding, starting winding, rotor circuit. So this also called as Rm and the Hn. So this is Rm and the Hn. So Rm and the Hn. So this is for the starting winding and the running winding. So starting winding and running winding are connected together. So this one in series, and this is connected to the supply. So this is for the running winding. So single phase induction motors we can draw the equivalent circuit diagram to starting winding and the running winding together. So that because of that there are two windings. So then these two wires we can make a combination. So combination will use this is the equivalent circuit. So this can mean that this circuit will use 2R1. So this is for the 2JH1. So this becomes 2JH2. So this is the 2R2. And then this is combination will use 2RM. So 2JHN. So this is the overall equivalent diagram. So approximate equivalent diagram we can draw like this. So this is for the equivalent circuit diagram for the three-phase single phase induction motor. Problems are this follows a single phase motor. So say a small 50 Hz. The hysteresis is a clock motor pulse in the 12 pulse. It makes it a one chance a hysteresis law is in the rotor is 0.8 joules. So find the pull in and the pull out torque. You will find the pull in and the pull out torque of this motor. And also there's a maximum power output when the motor is strong. And also you have to find the rotor losses when the motor is strong. And the rotor losses when the motor runs at the synchronous speed. Okay, firstly the pull in and the pull out torque you can calculate. The pull in, pull out. The formula is the motor voltage. So this is the power energy divided by the 6.28. In the motor energy law is 0.8 joule divided by 6.28. So this curve will be 0.127 Newton meter. So this is for the A. And the B means the motor synchronous speed has to maximum hour output before the motor stop. So in this case, maximum power needs to be calculated. P is a NT multiplied 9.55 equation. So in this case, you have to find the synchronous speed. So this is N has to 5. And this square root is 120 divided by P. So this is RPM. So RPM is this is for 120, number of pulls is 12, frequency is 50 Hz, number of pulls is 12. So there will be you got the thing. So this is for the 600 RPM. So this is 32 volts. 32 volts divided by 32. So they are 225 RPM. So we also find the P maximum power. So P maximum power is NT by 9.55. So the speed is 225. And store is 0.127 and 9.55. So by solving this one, the maximum power will be around for the 3 watts. So maximum power is we calculate as 3 watts. So this is for this motor maximum power. And then so the P. P also need to calculate the maximum power as rotor losses when the motor is stalled. So this is the rotor losses at stall. 32 volts. So in this case, the formula is RPM multiplies energy. The equation, so this is the RPM at 225, energy is 0.8, so you get this 180 joules. And then you have to calculate for the power. So this is for the rotor losses in the joule. And you can calculate the power. So this is the energy losses, energy divided by 60 seconds. So 180 by 60, so you got a 3 watts. So there we go. Rotor losses when the motor runs at synchronous speed, there will be no losses. So no energy losses. So this is for the characteristic of the synchronous machine. Today's topic is construction and properties of the single phase motor.